and what is this transmission medium means.
This call is now being recorded.
So transmission medium is nothing but whichever the sender is there, the sender if wants to send data to the receiver, it needs some medium. So using the medium, it can able to send the data. So the sender is sending data to the receiver using this transmission medium. And this transmission medium can be broadly categorized as two types. The first one is guided transmission medium, or we can say wired transmission medium, and the other one is wireless, or we can say unguided. So coming to the guided transmission medium, as the name suggests, guided means it is completely made up of wires, or we can say cables. So the wired transmission medium, again it can be of three types. The first one is twisted pair cable, second one coaxial cable, and the third one is fiber optic cable. So using these three modes of transmission, a wired transmission medium can be established. When coming to the unguided, or we can say wireless, as the name is suggesting wireless, there are no cables or wires between the sender and receiver. Only we can see the free space. How you are able to connect to the Wi-Fi? Whenever you are connecting to the Wi-Fi, are you finding any cables? We are not finding any type of cables. Simply using some signals, you are able to connect to the network, which we can say it is nothing but free space. Okay, so that is about your wireless. Now we will discuss one by one both guided and unguided. So coming to the guided, the first one we are having is twisted pair. So as the name suggests, the twisted pair. What is the meaning of twisting? Twisting means, what is the meaning of twisting? Anyone? Rotating, we can say. Okay, or see like this diagram, how the wires have been molded one after another, or one by one. So here this is one type of cable where the model looks like this one. So in this we can found two types of two cables or two wires that have been surrounded by one by one, and these wires internally they are having conductors. See, the twisted pair cable internally having conductors, and outside it is having insulator. So these conductors are made up of copper wires. Why? Because all of us we know copper is a good conductor for what? Electricity. So whenever you are sending data using the cable, automatically the data will be converted in the form of, in physical layer, what is the data format we are having? In physical layer, what is the data format? 505, Akshat Agrawal. 505. Are you there in the class or not? 510.
Yes,
510.
ma'am.
What is the data format in physical layer?
Binary data, ma'am.
Binary data. So the physical layer uses binary data, and that binary data will be converted into form of signals when it reaches to the transmission media. So the physical layer will convert the binary data to the signals in transmission media. All of us we will see the electrical wires. In electrical wires, what type of data you can observe in electrical wires? What type of data will be traveled using electrical wires?
Analog.
Anyone you can answer. What type of data will be transferred using electrical wires?
Analog.
Say loudly, Amma. 509.
Analog, ma'am.
It is not analog, that signals we can say. Okay, the data format, that means in the electrical wire we can found electrical signals. The signals you can categorize as again analog and digital, that is different, but we can found the data in electrical wires or cables in the form of signals. So those signals will be traveled using these particular cables. And the first one we are discussing here is twisted pair. The twisted pair looks like this one. And here, coming to this particular structure, the outer side, that is a pink color you are seeing, which is nothing but we can call it as insulator. And within this particular insulator, we can found the conductors. And these conductors, the material we are going to use for the conductor is copper. Why? Because copper is a good conductor for electricity. So the data will be traveled very fastly using the copper wires. So that is the reason the conductors you are going to use are with copper wires. And the insulator you can mostly it will be of plastic. Okay, the insulator, the material you are going to use for insulator is mostly of plastic. So this is about your twisted pair. Okay, so coming again, the twisted pair can be divided into two ways. That is UTP and STP. UTP cables and STP cables. UTP stands for unshielded twisted pair. Okay, UTP stands for unshielded twisted pair, whereas STP stands for shielded twisted pair. Okay, S stands for here shielded, and U here is unshielded, and TP is twisted pair. So coming to the UTP, this is the diagram of UTP. See here, you are having a twisted pair cable. Within again that twisted pair cable again covered with a plastic cover. Normally all of us we have seen in the previous diagram. This is your twisted pair. The outer part is nothing but your insulator. That insulator may be of, we can say, a plastic, and internally you are having a copper wires. Again when coming to the UTP, that insulator again covered with a plastic cover to give more protection. Why? Because to give more protection to the cable, you are going to cover this UTP with again a plastic cover. It is unshielded. Okay, and using this particular transmission, this particular twisted pair, mostly you are going to use for telephone communications. Okay, the twisted pair cables mostly you are going to use for telephone communication to carry the signals. When coming to the STP, that is shielded twisted pair, whatever the twisted pair cables you are having, those will be covered with a metallic shield, and again this metallic shield again covered with a plastic cover, which gives more protection and more data transfer, that is fast data transfer when compared to your UTP. Okay, the difference between UTP and STP is STP having one more metallic shield covering over the twisted pair, and that metallic shield covering will be again covered with your plastic cover, and this is having more data rate, or we can say fastest data transmission when compared to your UTP. All of you understood what is a twisted pair cable? Hello? Hello? 501. Understood or not? Archana. 18501. 511. 511. See whether you are there in the class or not. If you are not giving response, then how can I go to the next topic? Whether you are following or not.
Yes, ma'am.
Understood what is a twisted pair?
Yes, ma'am.
What is UTP stands for? UTP stands for
Unshielded twisted pair.
UTP stands for unshielded twisted pair, and STP stands for.
Shielded.
What is the difference between these two? UTP and STP? Difference between STP and UTP. 515. Praharsh. 515.
Yes, ma'am. Yes, ma'am.
What is the difference between UTP and STP? Just now I told you na.
Fastness.
Grounding.
Fastness. Along with that, the STP having one more
Grounding
covering.
cable.
Yes, one more covering with metallic shield for the twisted pair. Normally, the twisted pair, what is the covering it is having for the twisted pair? You're having a conductor which is made up of copper, and that copper wire will be enclosed or it will be covered with a insulator, and that insulator again covered with a metallic shield, and that metallic shield again covered with plastic cover in shielded twisted pair. When coming to the unshielded, the insulator of twisted pair is covered with only the plastic cover. Okay, so these are the differences between your UTP and STP. What is the next type of cable we are having in guided media? What is the next cable?
Coaxial cable.
Coaxial. Okay, the next guided medium we are having is coaxial cable. So as the name suggests, coaxial. See here, the structure of this coaxial cable looks like this. The inner part, or we can say the starting part, you are having the inner conductor. Okay, what is the conductor? Generally made up of metal. So here again we are going to use the copper for inner conductor. Why? Because copper is a good conductor for electricity. So the inner conductor is made up of copper wire. This inner conductor will be enclosed with an insulator. Why we need to use insulator for this copper conductor? Can anyone answer me? In the previous slide, that is twisted pair, also we are having the conductor that is enclosed with the insulator. Similarly, coming to the coaxial, the inner conductor is enclosed with the insulator. Why we need to enclose it with an insulator, the conductor?
Resistance.
Indama? Say loudly.
To separate it from other conductor.
మీరు ఎలక్ట్రికల్ వైర్స్, ఐ థింక్ హ్యావ్ యూ సీన్ ఎలక్ట్రికల్ వైర్స్, ఆల్ ఆఫ్ యూ? హ్యావ్ యూ సీన్ ఆర్ నాట్ ఎలక్ట్రికల్ వైర్స్?
Yes.
బయట కనిపిస్తుంటాయి కదమ్మా, అవునా?
Yes, ma'am.
What is the material you will observe outside? Some black color material. Yes, మీరు కేబుల్ వైర్స్ అవి చూసే ఉంటారు కదా. బయటకు ఏముంటుంది మీకు? బ్లాక్ కలర్ మెటీరియల్. ఇట్ మే బి ఆఫ్ ప్లాస్టిక్ ఆర్ రబ్బర్, we can say. Yes, yes or not?
Yes, ma'am.
దాంట్ లోపల ఏముంటాయి మీకు? వాట్ విల్ బి దేర్ ఇన్సైడ్ దట్ పర్టికులర్ మెటీరియల్? సమ్ వైర్స్ which is made up of metal. We can call them as conductors. మీకు పైన అవుట్ సైడ్ ఏమీ లేకుండా జస్ట్ వైర్సే ఉన్నాయనుకోండి, or that metal conductors are there, can you able to touch them?
No.
Because we will get shock. To prevent that one, that particular conductors are covered with the insulator. Okay, that is the main reason all the conductors are covered with insulators. And to give more protection, the insulator is again covered with different materials. So here, coming to the coaxial cable, the inner conductor is copper. That conductor again covered with an insulator. Again, this insulator again covered with one more outer conductor. Again, this outer conductor is also one metal. See here, the outer conductor of coaxial cable is also one more metal. And again, that outer conductor again covered with one insulator. Again, it will be like maybe some material or rubber or whatever it may be. And again, that outer, this particular insulator again covered with a plastic cover. So this is how the coaxial cable covering will be done for an inner conductor. And this is the structure of your coaxial cable. Now, what is the role of this inner conductor? As I told you, the copper wire. What is the role of this copper wire in twisted pair or coaxial cable?
Carry current.
To carry the data between sender and receiver. That is, what type of data it is going to carry?
బైనరీ డేటా
బైనరీ డేటా అనేది ఏ లేయర్లో ఉంటుంది మీకు? ఇన్ విచ్ లేయర్ వీఆర్ హ్యావింగ్ బైనరీ డేటా?
ఫిజికల్.
ఫిజికల్ లేయర్. ట్రాన్స్మిషన్ మీడియం అనేది ఏంటి? వాట్ ఈస్ ద ట్రాన్స్మిషన్ మీడియం?
Which medium it carries?
That carries the data. So whatever the data that is there in physical layer, that binary data will be converted into signals. మీరు ఎలక్ట్రికల్ సిగ్నల్స్ అంటాం, అంతేగాని ఎలక్ట్రికల్ బైనరీ డేటా అంటారా మీరు? whenever we are saying, we will call them as electrical signals. Can we call them as electrical binary data? ఎలక్ట్రికల్ బైనరీ డేటా అనం కదమ్మా మనం. హలో హలో
Yes, ma'am.
we will call them as signals only. Why? Because the data will be, the binary data will be converted into signals. So again, the signals can be of analog or digital. As I told you, analog means it will be like waveform. I think all of you know how the wave will be, up and down. When coming to the digital, it will be like bar graphs. మీకు ఒకసారి డయాగ్రామ్ కూడా వేసి చూపించాను నేను. You remembered or not? So coming to the conductor that carries the electrical signals. So now what is the need of this coaxial cable? This will be mainly used for cable TV networks. So the coaxial cable mostly used for cable TV networks and for your LANs, local area networks. Okay, this is nothing but your coaxial cable. What is the third one we are having? What is the third guided medium we are having? Fiber optics. So coming to the fiber optics, this we can say this is the latest technology that will be implemented for, as a transmission media nowadays. I think all of you had heard about optical cables. Did you heard about optical fiber cables? Heard or not?
Yes, ma'am.
మీరు చాలా చోట్ల రోడ్డు మీద కూడా చూసుంటారు. We will have some చిన్న చిన్నవి ఉంటాయి కదమ్మా, ఓఎఫ్సి కేబుల్స్ అని చెప్పేసి ఉంటాయి కదా మీకు బోర్డ్స్. Have you seen that one or not? That OFC stands for optical fiber cable. Nowadays, as the technology is increasing and every user, whoever using the internet, they want more faster networking facilities. So that is the reason nowadays the previous cables have been replaced with optical fiber cables. So whatever the previous cables we are having, that is coaxial cables or twisted pair cables, have been replaced with optical fiber cables. So what is this optical fiber cable? What material it is going to consist of? And what is the conductor here we are using? Previously in twisted pair and coaxial cable, what is the conductor we are using? What is which copper we are using? But here optical fiber. Optical. What is the meaning of optics? Did you heard the word optics?
Yes, ma'am.
What is meant by optics?
రైట్
ఏంటమ్మా? Say loudly.
లైట్
Light. Very good. Optics is nothing but light. So as we are here, the transmission medium uses the conductor as light because light having faster data rate transmission. Yes or not? Light is having very fast transmission of data. మీకు థండర్స్ లైట్నింగ్ వచ్చినప్పుడు which one will comes first? When it is raining heavily, we will observe thunders and lightning. Yes, among these thunders and lightning, which one will come first? General knowledge question. మీరు అందరూ చిన్నప్పుడు నుంచి చదువుకునే ఉంటారు. Which one will come first?
Thunder.
Thunder.
రైట్
Why? మీకు ఫస్ట్ లైటింగ్ వచ్చి తర్వాత థండర్స్ వస్తాయి. వై? బికాస్ లైట్ ఈస్ ద ఫాస్టెస్ట్ మీన్స్ ఆఫ్ ట్రాన్స్మిషన్. సో హియర్ based on that concept, Here, the transmission medium they have selected is optical fiber. So this particular optical fiber will looks like this one. See this diagram. The sender you are having and receiver. The sender will send the data. Sender ante here normal user. Now in which format the user is sending the data? High level language. But when it reaches to the physical layer, what is the data format it is going to convert? Binary data. That binary data will be converted in the form of light signals here. Okay, the type of signals here is light signals. So this light signals will be passed through this beam. We can call this as a beam to the receiver, and this beam will be surrounded with a cladding. Okay, this beam will be surrounded with a cladding. So now this optical fiber cable consists of one beam, which is nothing but optical fiber optical beam. That beam should be surrounded with a cladding. So whatever the light beam that is sending, it will be passed like this. See, it is having up and down arrow direction. So the light will be sent in this particular manner. Why we need to send in this manner means, whatever the cladding material here they are using, that material mostly made up of glass or plastic. Okay, the cladding material mostly made up of either with glass or plastic. If one question I will ask, if a light beam touches the glass surface, what will happen? If a light beam, or if you pass light through a glass, what will happen? Whether it will you will get reflection or not?
Yes, ma'am.
Yes, you will get reflection. That means it touches the glass surface again, it will revert back. In the similar manner, this is happening. See, when a light beam is passing, it touches the glass surface, again it is going to get reflection. Again, by touching this surface, again it will go to reflection. Like this particular beam will be passing. Okay. Now coming to the propagation modes. That means whatever the optical signals you are using, when you are sending the data through this particular cladding, what are the different propagation modes we are having? That is, propagation mode is nothing but how you are sending the data. So here we can classify the propagation modes into multi-mode and single mode. Okay, we can classify mainly the propagation mode into multi-mode and single mode. Again, the multi-mode can be classified as step index and graded index. Okay, the multi-mode having, again we are having sub-classification as step index and graded index. We will see one by one. Here, see this diagram. The first one, multi-mode step index. Okay, the first diagram shows multi-mode step index. ఇక్కడ మీకు క్లియర్గా చెప్తాను. Have you seen this first diagram? All of you seeing the first diagram? Are you seeing or not?
Yes, ma'am.
So coming to the source, here we are having some form of data. The source is sending some form of data. Have you seen this one? The format like bar graph. So this data format we can call it as a digital signal. Okay, if you are having a data in this format or signals in this format, it is nothing but digital signals. And here when coming to the destination, it is like a wave. Yes, have you seen this destination? The signals will be in the form of wave. This type of data or signals we will call them as analog signals. Okay, whatever the signals if you are having in this format like wave, that type of signals you can call them as analog signals. And if you are having a signals like this format like source, these type of signals we can call them as digital signals. Now all of you clear what is a digital signal and what is an analog signal? Hello?
No, ma'am. Once again, explain, ma'am.
Here coming to the source, have you seen the signal diagram here? It is like a bar graph. Bar graph, I think all of you are having the idea of bar graph. How it will be? Whenever you are drawing a graph using bar graph, you are going to draw rectangular shapes in the graph. Yes, you are going to mark the rectangular shapes in the graph. Yes or not? Hello.
Yes, ma'am.
Yes, ma'am.
Here in the source side, you are having a data like this. This type of data, you are going to call them as a digital data. Okay? Understood? This is a digital data. If a data is representing, that is signal, if a signal is represented in this format, you can call it as a digital signal. But if a signal is looking like this wave, I think all of you know how the wave looks like this only, destination side. Yes, up and down. So this type of signals we can call them as analog signals. మా అర్థమైందా డిజిటల్ అనలాగ్ డిఫరెన్స్? హలో.
Yes, ma'am. If the source is also same, then it means that it is.
ఏంటమ్మా?
Uh,
సే లౌడ్లీ.
wait.
హలో.
If the source and destination is same, then it is analog, ma'am.
కాదమ్మా, ఇక్కడ డయాగ్రామ్ ఎలా ఉంది సోర్స్ దగ్గర మీకు?
Bar graph like.
బార్ గ్రాఫ్ లా ఉంది, లైక్ రెక్టాంగులర్ షేప్స్. సి హియర్ మీకు ఎలా ఉంది కదా అక్కడ డేటా,
Yes, ma'am.
అవునా కదా?
Yes,
This is
ma'am.
nothing but your source. That means here the lower one we can call it as 0. Okay, మీకు కిందన బాటమ్ లైన్ ని we can call it as a 0. టాప్ వన్ we can call it as 1. మీకు బైనరీ డేటా ఉంటుంది ఫిజికల్ లేయర్ లో. yes or not? The physical layer having binary data. That binary data will be converted in the form of signals. So whenever it is going to convert in the form of signals based on the data, suppose you have sent 0 0, మీరు 0 0 పంపించారు, what will happen? Your data will be in a straight line like this. Suppose you have sent 1, then what will happen? It will raise like this. So 1 will appear here. Are you following?
Yes, ma'am.
So 0 అంటే బాటమ్, 1 మీన్స్ అప్. మీకు డిజిటల్కి వచ్చినప్పుడు ఏమవుతుంది? 0 మీన్స్ కంప్లీట్లీ ఇట్ విల్ గోయింగ్ డౌన్, విచ్ గివ్స్ మోర్ యాక్యురసీ. Similarly, if you have sent 0 1, then 0 1, again 0 1 you send, again 0, again 1. So like that it is going to maintain accuracy. మీరు 1 అన్నప్పుడు కంప్లీట్ గా 1 దగ్గరికి వెళ్ళిపోతుంది. సో more accurate you are having. If you are going to 0, automatically it is completely going down. So this is nothing but your digital. But when coming to the analog, here also the data will be in the form of zeros and ones only. So 1 means the up one, like here you are having the mountain high, and 0 means the bottom. But coming to the accuracy, as it is not a steep, it is how it is like a sliding. Yes, when it is coming from 1 to 0, it is like a curve. Again from 0 to 1, again it is like a curve. It is not maintaining the accuracy. Okay, that is the reason nowadays whatever the technology we are using, like for data transmission, mostly we are going for digitalization. Nowadays, I think all of you know about cable TV. Meeku cable TV, I think all of you having the idea of cable TV, yes? Hello?
Yes, ma'am.
Previously, I think past before 5 years, what is the type of technology they are going to use for cable TV? And now what you are using? Now we are using digitalization. Yes, did you remember or not? Now we are using digitalization set-top boxes. I think every cable TV you are having a set-top box. Yes?
Yes, ma'am.
Hello?
Yes, ma'am.
Yes, ma'am.
What is the need of that set-top box? It will convert the data into digital format. Previously, we are not having set-top boxes for cable TV directly. They are going to give one pin. Using that pin, you are able to connect to the TV. So that time we are having analog data transmission. But when it became digitalization, automatically we came up with the set-top box concept, and this digitalization is nothing but it uses the digital signals. Now what is the difference between digital signal and analog signals? Digital signals having more accuracy, that means they will give more clarity when compared to your analog signals. Why? Because analog signals are in the it is not maintaining the accuracy because of its shape, wave shape. But when coming to the digital signals, it is maintaining accuracy based on the given data. So digital signals having more accuracy when compared to your analog signals. All of you understood difference between analog and digital signals? The best example I can give you for is cable TV only. Understood or not? Hello.
Yes, ma'am.
Yes, ma'am.
Now we are discussing the first mode, that is propagation mode of optical fiber, that is multi-mode. Under multi-mode, what is the first one we are having? Step index. So coming to the multi-mode step index, what is the medium you are using here? Optical fiber, and the signals you are sending here are optical signals. As the name is suggesting, multi-mode. So here multiple beams are sending through the cladding. Okay, in step index, multiple beams, that means more than one beam you are sending. Here how many beams you are sending here in this diagram? How many beams we are sending?
3.
3 beams. So what will happen? The step index, according to our optical fiber cable concept, what it will do? Whatever the beam that is entering into the cladding, it will touches the surface. That means step by step it is going. So that is the reason we named it as step index. So whatever the optical beams that are passing through this multi-mode, those will gone for reflection of light, reflection of this particular surface. And what will happen? The data will be passed in a step manner as it is touching the surface using the refraction method, and coming to the output, it will generate again analog signals. So it will send the digital signals as the data, and when coming to the upon reaching to the destination, it will convert as a analog signals. So this is nothing but your multi-mode step index. In multi-mode step index, you can able to send more than one beam at a time. Okay. But when coming to the accuracy here, what will happen? As you are sending multiple beams at a time, as all these beams are passing through single cladding or single cable, the accuracy you may lose because every time it is touching the surfaces. So while it is touching the surfaces, what will happen? Some disturbance or noise it will come in the step index. So to overcome that one, we are having another mode under multi-mode, which is nothing but graded index. Okay, multi-mode graded index. In this, only single beam is passing. Okay, a single beam is passed, and this beam will undergoes reflection and diffraction. But as we are passing a single beam, it will not having any type of disturbances, and you can maintain the accuracy. Okay, this is nothing but your multi-mode step index and graded index. And another one we are having is single mode. Okay, the last mode of propagation, that is single mode. So here coming to the single mode propagation, single mode, a single beam is passing without any reflection. That means a single beam is passing in a straight line that should not undergone for any type of reflection to the surface. Now what is happening here? As the beam is passing in a straight line, you will get more accuracy when compared to the previous one, and the data speed is also more when compared to the single mode. As you are passing a single beam in a straight line, the data transfer is more faster when compared to the other modes of propagation. So this is about your optical fiber. Understood all of you guided medium? Hello? Ma, have you understood or not guided medium?
Ma'am, what is the difference between step index and graded index, ma'am? Both are having multiple data lines.
In graded index, only one beam you are sending. See here. A single beam you are sending. In step index, how many beams you are sending here?
3.
But in here, you are sending only one beam. Okay. Now the next one we are having is unguided media. That is nothing but wireless transmission. So as the name suggests, wireless, it uses the medium as air, or we can say free space. As the name suggests, wireless, it uses the transmission medium as air, or we can say free space. So this unguided media, again, it can be divided into 3 ways. Okay, we can divide the unguided media or wireless transmission into 3 ways. The first one is radio wave, the second one is microwave, and the third one is infrared. Okay, now whatever the transmission medium we are using, that is Wi-Fi transmission, we can say wireless transmission, it can be divided in 3 ways. That is whatever the air we are using for the transmission of data, that air can be divided as 3 waves, that is radio waves, microwaves and infrared waves. Now we will discuss one by one. See this diagram. So in this diagram gives you what is the range of each wave. So coming to the radio waves and microwave. So radio waves mostly used for multicast transmission. Okay, radio waves are mostly used for multicast transmission, such as your radios. I think all of you know about FM radio. Yes? Yes or not? FM radio.
Yes, ma'am.
What is FM stands for?
Frequency modulation.
Yes, very good. FM stands for frequency modulation. So whatever the FM we are having, that uses the frequency in the air of 3 kilohertz to 300 gigahertz. So that means it uses the frequency band of 3 kilohertz to 300 gigahertz in the air. And coming to the microwaves, the microwaves also fall within the same range, that is 3 kilohertz to 300 gigahertz. And where you are going to use the microwaves? These microwaves you are going to use for cellular networks, or for satellite networks, or for Wi-Fi wireless LANs. Okay, mostly the microwaves you are going to use for cellular networks or satellites, or we can go for LANs. Now coming to this direction, that means how these waves are going to be passed are nothing but omnidirectional. See the antenna of this particular radio waves. So I think all of you know this type of antennas, yes? Yes or not? Have you seen such type of antennas? Hello? Hello?
Yes.
Is it audible or not?
Yes, ma'am.
So what is the meaning of this structure of antenna? Means it is omnidirectional. That means the waves can be passed in all the directions. Okay, it is not restricted. The waves can be passed in all the directions. So this is about your radio and microwaves. And the next one we are having is infrared. So infrared waves fall under the frequency range of 300 to 400, 300 gigahertz to 400 terahertz. So where you are going to use this infrared waves? Mostly for televisions. I think all of you know TV remote. Yes, TV remote uses the infrared technology. Okay, TV remote uses the infrared technology. Now, what is the difference between these radio waves, microwaves, and infrared? So, coming to the infrared, you cannot, if an obstacle exists between the wave and the media and the destination, then the rays cannot be passed. Have you observed or not? If an obstacle appears between your remote and the TV, will it operate? Hello? Hello? People not there in the class?
No, ma'am.
Hello? 509.
No, ma'am.
Why you people voice is not audible? Hello?
Yes, ma'am.
While you're operating the TV remote, if an obstacle comes between your TV and your remote, can you operate with the remote?
No, ma'am.
So it uses the technology of infrared. So that is the drawback of infrared, and it is used for only limited area, or we can say the restriction of this infrared is very limited within a room. Okay, and if an obstacle occurs also, the rays cannot be passed. But when coming to the radio and microwaves, as those are omnidirectional, you can use the waves will be passed through air, and it will have more range. So that is the reason our mobile phones or whatever the Wi-Fi networks we are using, all are made up of all are using the radio and microwaves. And one more we are having is light wave. So light wave falls under 400 terahertz to 900 terahertz. Okay, but still the light wave implementation is not there. We are using only radio waves, microwaves, and infrared waves. Okay, this is about your unguided media. Okay, understood all of you? Hello? With this,
Yes,
we
ma'am.
completed unit 1. See here. The overview of the networks, topology, protocols, layering scenario, TCP/IP protocol suite, OSI model, internet history and standards, comparison of OSI and TCP/IP models, and the first layer of your TCP/IP is physical layer, that is guided medium and unguided medium, or we can say wireless transmission medium. So all of you understood all the concepts, or if you are having any doubts, you can ask. Hello? Have you understood or not? మా మీరు రెస్పాన్స్ ఇస్తేనే కదా మనకు తెలిసేది. మీరు రెస్పాన్స్ ఇవ్వకుండా సింపుల్గా క్వైట్గా ఉంటే హౌ కెన్ ఐ అండర్స్టూడ్ వెదర్ యు ఆర్ ఫాలోయింగ్ ఆర్ నాట్? హలో? If you are not giving response, shall I move to the next or next unit or not? Okay, next class again I will revise all the topics of unit 1, and before that I want to give you one assignment. Who is the CR of your class? CR.
Yes, ma'am.
44. What you will do is you create one link. Okay, you
Yes, ma'am.
create one Google link, and all of you create folders with your roll number. All the class, whichever the link will be created by your CR, all of you create a folder with your roll number, and whatever the assignment I will send you, I will post the assignment in the link only. Okay, I will upload the assignment in the link only, and you need to submit the assignment whatever the folder you created with your roll number. Okay, you need to upload your assignment with whatever the folder you have created with your roll number. You need to upload within in that particular folder. Must and should everyone has to create the folder. Individual గా పంపించొద్దమ్మా. All of you create a folder, and CR you create one link. When you
Yes.
create the link?
I'll do it today evening.
Today. Okay, by today evening will you create?
Yes, ma'am.
Then I will upload the assignment questions in that particular link, and all of you create folder with your roll number and upload the assignment after completing the assignment in that particular folder. So unit 1 is very important and basic unit. If you understood this unit, then only we can go with the next topics. That is the next unit is the second layer of your TCP/IP. What is the second layer of TCP/IP? After physical layer, what is the next layer you are having?
application.
Physical layer తర్వాత application layer. Data link layer.
Data link.
After data link, we are having network, and after network, we are having transport, and after that, we are having application. So each unit, you are going to interact with one layer in detail and in depth. So that is the reason all of you must aware of the concepts of unit 1, and you have to remember all the concepts of unit 1.
Ma'am, share the notes, ma'am. with
Adya,
PPT.
that's what I'm saying. After creating the link, I will upload the notes in the particular link only. Okay?
Ma'am, syllabus copy also, ma'am.
Okay, okay. Syllabus copy, I will create a folder with CN. Okay? I will create a folder with CN material. In that folder only, I will upload the notes, assignment questions, everything.
Okay, ma'am.
Answer a roll call. Roll number 1,
Present, ma'am.
2,
Present, ma'am.
3. Roll number 3, 4,
Present, ma'am.
5,
Present, ma'am.
6,
Present, ma'am.
7. Roll number 7, 8, 9,
Present, ma'am.
10,
Yes, ma'am.
11. 11 is not there.
Yes,
12,
ma'am. 11, yes, ma'am.
12. Roll number 12, 13, 15,
Present, ma'am. 15.
16, 16, 17, 18, 18,
Present, ma'am.
19,
Present, ma'am.
21,
Present, ma'am.
22,
Present, ma'am.
23,
Yes, ma'am.
24,
Present, ma'am.
25,
Present, ma'am.
27,
Yes, ma'am.
28,
Present, ma'am.
29,
Present,
29,
ma'am.
30, 30,
Present, ma'am.
31,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35,
Present, ma'am.
36,
Present, ma'am.
37,
Yes, ma'am.
38,
Present, ma'am.
39, 39, 40, 40,
Present, ma'am.
41,
Present, ma'am.
42,
Present, ma'am.
43,